Okay, everyone here for this talk? What? This girl in the front, she's still filming. I'm going to be all over Facebook right now. So I have this software called Mgmt. I'm going to talk about what's possible right now, and I'm going to show you a lot of demos. I talk really fast, so if you're really lost, just let me know. But I have only 30 minutes, so I'm going to try and go really, really quickly, and you can ask me questions after too. And also, I'm giving a super advanced talk tomorrow, so you can check out that. I'm a hacker. I work on config management stuff. I write a technical blog called The Technical Blog of James. Who's seen my blog? Just raise your hand. If you haven't, just raise your hand so I seem really popular. Everyone, raise your hands. The Germans are still sleeping. I'm actually a physiologist by training. So if you actually want to talk about cardiology, I love talking about that stuff and nerding out. And I'm big into DevOps stuff. And just some background. I used to do like Puppet for many, many years. And Beaker's just screaming because everything's on fire and it's pretty terrible. Nowadays, everyone's YAMLing, like Ansible, like Kubernetes, and like what's going on? Like I don't understand. And someone has made this like YAML assembler. I don't even know what this is. Do you know what this is? Has anyone heard of this? It's like you can look at the terrible link. There's this like really fancy project that Google just released that does this like super fancy YAML generating with this language thing. It's just completely nonsense. Everyone writes some code to like build infrastructure, but to tell this code what to do, we blast a whole bunch of YAML at it. I just think it doesn't make any sense. So the real question is, do you really want to be YAML programmers? No? Who said yes? Oh my goodness. This is the gentleman who will answer appropriately. I'm definitely in the nope camp. Fun YAML fact, so like if you truncate a YAML file somewhere in the middle, it's potentially still valid YAML. So if your code gets truncated for different reasons, it can actually happen. You might run like partial code, quote, and it's all bad. So long story short, some time ago I started this project called Mgmt. We have this cool logo and stickers, so if you want, come get a sticker at the end. I actually have a talk here 2 years ago. This is me. Not as good looking as I was back then, but you can see this great YouTube talk about what I was presenting, and quite a lot has happened in those last 2 years. So I'm going to sort of build on this and assume a bit of knowledge, but show you what's going on these days. 2017, look at that. This is like a slide I had with future work of stuff to do. So we didn't have a language, so lexer, parser, wasn't declarative. All these things, these lightning bolts that I've made in LibreOffice mean that they're done now. So all the stuff that I promised to do 2 years later is actually done. This is only half done, but it's not important. And anyways, the tool has two main parts. It has an engine, which actually does work on the machine, and a language. And back to this whole thing why I don't like the YAML approach. The goal we're really trying to solve is we have like some sort of infrastructure that we want to build in our data center, right? And we have to use our minds to somehow convince the computers to do what we want. And we can't just like mind meld. That would be so awesome. If we could just like mind meld, everything would be perfect. Except the computers, we would know what we were thinking, and that's bad. But, so instead, we need to actually describe how we want our data center to look over time. And for me, I don't think that's really possible with YAML. We need to actually describe the time component and everything. So there's these two parts. The engine itself, it's very similar to Puppet. Who's done something like Puppet before? Okay, so I'm going to assume some knowledge. So basically, we have a graph of resources that we run, similar to Puppet. The difference is ours actually can run in parallel, and it's event-driven, and it works as a distributed system as well, which I'll show you in a moment. You want to see a quick demo of this? No? Come on, wake up. Okay, cool. So I've actually running this all on my laptop. Is that big enough for everyone to see in the back? Yeah? Okay, good. So I just actually going to run a simple example, this nspawn run. So I'm running Mgmt on the left over here. I'll just type my password, which is password. So Mgmt is running, and it runs continuously. And if I do this machinectl, oops, I need to do, I'm just going to show you what machines are running. So you can see Mgmt is running, and it started up an nspawn container. Nspawn is like a container thing. It's like a better Docker. And you can see it's running. And if I machinectl again, if I actually terminate it, you can see it comes right back. So Mgmt notices that the state changed, because I was annoying and I poked it, and it woke up, and it put this machine right back. See it right here? It's still running. And so this is the whole point. So everything is live and in real time. Now hopefully you're not a sysadmin that pokes things on your machine to break them, but if you do, it will repair the state. And the reason we do this is actually different, but that's just the sort of general idea. We can have these real-time running resources that manage their state, and that means also that if we want to change the state, we can do it in milliseconds. We don't have to wait another 30 minutes for Puppet to run again. Cool? This guy's face is like, wow, I did not know this was possible. Or that's what I'm assuming. Am I right? Yeah, he says yeah. Okay. So, make sense? No? Everyone's quiet. If you don't answer me, I'll never know if I'm going way over your heads. Do you want to see more demos, or have you had enough? More? Burn. Get these guys to wake up, and girls. Okay. So now let's talk about the language. I'll show you actually really quickly how I actually built this. Oops. All this code, by the way, it's all open source, all on GitHub. You can see, basically, I just have an nspawn resource, and it looks very similar to Puppet. So you say, I want the state of this container or this resource to be running, or whatever. And here's a few things how I actually caused this to build the container from scratch. So you can actually run all this on your own and look at it slowly. Let's go back here. So the way we describe things is in this language. And we want a language which is safe, right? Because if you make a mistake, you don't want to blow away a data center. We want it to be very powerful. So our language is something that's called Reactive, which I'll show you in a moment. And we want it to be easy to reason about. So it's a DSL that gives you tools that are just for this job. So here's the first demo I'm going to show you. So you can see here I have this datetime function, and then I add it to a year, which is this variable down here. And then we put that value into this big struct, which gets put into this template, which goes into this file, so temp whatever. So what's going on? Let's actually run this. Okay, so I'm going to run this on the left. Now MGMT is running continuously, and if I watch, I'm just going to watch this file. So what I'm doing is MGMT is actually running, and for whatever reason, it's continuously changing this text file that I'm putting over here on your right. And what that is just whatever it happens to want to do. And in this case, remember it had this datetime function that I showed? This datetime function is not a normal function that you would find in a regular programming language. It's a function that instead of returning one value, it returns a stream of values. And that stream of values gets pushed through the system, reevaluating the code that needs reevaluation. So in this case, it's the number of seconds since 1970. So we take that value, we add it to this other value, push this all through, and then add a whole bunch of other things together, including the system load, which comes from a system load function. And if you look, you can actually see these values are changing in real time. Does that make sense? And just to show off a little bit, so this last thing at the bottom, I actually built a VU meter function, which is actually using my laptop microphone right now. And if you make noise, you can see that it goes up. And so what this is really doing is we're taking all of these real-time values, we're integrating them in a closed feedback system, and doing some result. In this case, it's just sort of silly. We're doing a VU meter for fun. But it could be something completely different. So just to test this, if I'm really quiet, when I point to you, I want you to make as much noise as possible and see how far you can get. Are you ready? Let's be quiet. Pretty good. So not fake. And what could you use this for? I always make this joke that like you could have this running in your server room, and if you hear a lot of screaming, maybe there's a fight, and you could automatically set everything read-only, right? Just to wait until people stop fighting. Okay? Does that make sense? Okay, so I've showed this demo before, but let's make this a little bit harder. Let's do some fancier things. You want to do some fancier things? This side wants fancy. This side is like in shock. You want to see some fancier stuff? Okay, let's keep going. So just a really quick sort of less fun note, we actually have this whole module system. So unlike Puppet where you can't actually namespace things, this is all super easy to namespace. Here's a little slide you can look at so you can actually build different modules and import them as something or other and use that. So that's how it works. You can run the language in a whole bunch of different ways, but let's do something magic. You want to see some magic CPUs? Okay, so I have to just first, I have to start up this virtual machine. I'm just going to have MGMT, oops, first list. Okay, that's good. So what I'm going to doing right here is on the right, I'm just going to log in to this VM that I've started up. If it's starting up. Okay, oops. Root, my password is secret. So I have a VM running on the right. And I'm just going to run some kernel stuff, just as it's going to turn off logging so that we don't see too much noise from the kernel. And I'm going to run this display CPUs command. And what this is doing is it's just running over and over again in a loop. And it's going to show you the number of CPUs on this virtual machine. And also what I'm going to do, let me just actually start screen, sorry. So we can have two windows on that. And I'm going to run on this machine, normally you would have the VM boot up and MGMT would run automatically. But I want you to actually see the logs of what's happening, so I'm going to actually just run it manually. This little script. Okay, and then over here, I'm just running the shell script, which is just going to loop and print out the number of CPUs in that machine. Does that make sense? Now over here, I'm going to run MGMT on my local machine, the host. And so MGMT is running, and I'll just show you the code that MGMT is actually running. And all this you can do at home. For 2, I think. And what MGMT is doing, it just has some code here that it basically reads an integer from this text file on my computer. And if it takes that integer and it puts it into this virtual machine resource right here, into the CPU count. And here's what happens. If we go and we echo, say, 2 to that file, what's going to happen is MGMT is going to notice that that file changed, because we're watching that with this real-time input source. Just how we took the microphone input, here we're taking a text file input. We're going to take that text file, we're going to read the integer out of it, and in this case it'll be a 2 or a 7 or whatever, and we'll take that value and stick it into the MGMT language in the CPU's field for the virt machine resource, which is the thing running over there. Now, the moment we change that CPU count, the VM is going to say, oh, I'm the wrong number, and so MGMT will hot plug or hot unplug a CPU for us. Now, the MGMT inside that VM is going to notice that, hey, the CPU count changed, and it will actually change the text file, which we actually see printing out this little message. We see number of 1 CPUs. That's just MGMT printing out that message. Does that make sense? Should we run it? Are you ready? Boom, it's done. And we can do that again. So you see, I'll run it to 4, for example. So I press enter, MGMT notices that it changed. It quickly hot plugs the CPUs. On the right, it sees those new CPUs very quickly, and it runs MGMT with that new change. And you can go back down to 2, for example. And just to show off, should we show off a little bit more? Is that cool? Do you like that? Yes? You can clap. Thank you. So just to show off a little bit, I have this little Delta CPU script that basically just echoes to a text file, just for fun, for theatrics. And basically, if I do plus or minus, I don't know if you can see me pushing the key, but in real time, it's very, very quick. Do you like that? And so the whole point of this is we're building these real-time dynamic systems where we integrate data in milliseconds, in seconds. So the whole idea is you would look at the load, and when you have a lot of load and you need more CPU, you could like automatically add some VMs, hot plugging them, add some CPUs to your VMs, hot plugging them, doing that job, and when it settles down, like automatically rebalancing your workloads or any sort of crazy thing that you want. MGMT doesn't care what you build with it. We're just a tool that is hopefully giving you a tool and a language that lets you be expressive the way you want. And here's just one example. Cool? Do you want to see more, or is that enough? Okay, they're getting slightly louder burned. Every time I show more demos, they wake up even more. So, okay. So we actually have to kill MGMT. We'll just kill all this quickly, just so that we don't have to watch it all shut down. Okay. So I'm just going to destroy this VM because we don't need it right now. Okay. So magic CPUs. So this actually showed a few different features. One, we have a virtual machine resource. It's based on libvirt, so it can use anything that libvirt does, and it lets you hot plug and hot unplug machines, CPUs. And we also have a variable, like it's basically a special function in the MGMT language that detects how many CPUs are on the machine. So that's what we use if we want to do an expression. You know, if CPU count is greater than something, do this, otherwise do that, or just print out the value. And that actually gets messages from the kernel every time the CPU count changes and feeds that into MGMT. And there's hundreds of these little functions, many of which we haven't even written yet, to get new data sources into MGMT. And they're very simple to write, and you could write one in a few hours or less. Cool? Are you all going to write one for some cool thing? All right. Do you want to see something about scheduling? Anyone? No? Okay, I'm waiting until I hear a solid yes from the crowd. Do you want to see a really cool distributed scheduling demo? Oh my God. Bernd, I'm sorry, I'm not coming back next year. They're very quiet. Okay, so here's what I'm going to show you. So I've told you we've all been doing basically single machine things. But it turns out this MGMT, it runs as an agent, and you can run it on multiple machines, and they actually all cluster together using an algorithm called RAFT. It has to do with distributed consensus and all sorts of fancy stuff that none of us understand. We're just going to pretend it does work for the moment. So here's some code that I'm going to run, and I'm going to run this on each machine in the cluster. Now, it could spin up 4 different VMs, but just to keep things simple, I'm going to run everything on my local machine just because it's way faster. Is that cool? The only catch is we have to specify different ports manually because normally they all use the same port. And what the code is going to look like is something like this. So we have this options variable, which is a struct, which just takes some fields. So strategy equals RR, max equals 2, TTL equals 10. And this options variable goes into this schedule function. Remember, functions return streams of values. It has a namespace and the options. And what it will do is this function will run on every machine in the cluster. And every machine in the cluster will tell the rest of the cluster its host name. And somehow with distributed consensus magic, the function on each machine will independently agree on which machines to choose from the available set. So if you have 3 machines running and we've asked it to pick 2, it'll return an array of those 2 chosen machines. And then down here at the bottom, what we do is we just pick which machine to run it on and do something. So if you're scheduled, if you're in the set, run the thing. Now we can do this as a regular demo, or we can do this with a Docker container. Which would you prefer? You really want the Docker thing? Okay. Okay, we'll do the Docker thing. So I'm going to run just a multiple MGMT agents right here. And let's see, what's the command? Okay, so I'm going to run this big watch command here, which should show you what's happening. So what I had the code create a Docker container on each machine and run a little thing saying who's scheduled and who's the set of scheduling. So I ran one machine, and so now I'm going to start up a second one. Again, so it looks a little scary, but it's basically just the URLs to change stuff. So I'm running a second machine. They're grouping together, and you can see in a moment, this is basically the output from the first machine. It says, I'm H1, hostname H1, I'm scheduled, and the people who are scheduled, or the machines, are H1 and H2. On H2, you can see it also thinks that it's scheduled, and it sees that H1 and H2 are also scheduled. And if you look down here, I'm just running a Docker PS. You can see that I've started up 2 containers. One is called D-H2, which is the one that the second host schedules, and this one is called D.H1. Okay? Does that make sense? It's a bit tricky to see. But watch what happens when I start up a third one. So I'm starting up a third one. They're clustering together. And you can see that nothing has changed. Because if you remember, in the code, we said max of 2. So the scheduler was told, pick a maximum of 2 hosts, please. And assuming there's no bugs in my code, watch what happens when I kill H2. If I kill H2, you can see something happens, and boom, this one switched to being H3. So it noticed, hey, I'm missing a host. Now we need to have a new one. And so H3 took over and is now scheduling the third Docker container. So it's Docker H3 and Docker H1. Does everyone see that? And what if we start up H2 again? Usually it doesn't change. So it has, it recognizes that it doesn't want you to flip-flop. So you can see that H1 and H3 are still there until maybe you kill H3 again. And it'll switch over to H2. You see that? Is that cool? Okay. Oh, we got some enthusiastic clap. So the idea behind this is you might want a scheduler. You might want to do auto-scaling with VMs. You might want to make some decision that impacts a whole bunch of machines in your cluster. So which one to elect as the primary host or something like that. All of these complex logical things, you just cannot express them with all the different possible variations of YAML files out there. It's just not possible. Or at least I don't think it's possible. It's only possible if you constrain yourself to very small, common types of infrastructure. And if you want to build different things that's really much more custom for your infrastructure, the language hopefully gives you the power and the flexibility to build the custom thing that's very safe. That make sense? I have 10 more minutes. You want to see more demos, or are you fed up for the day? Okay, if I don't hear a resounding more demos, like, I'm going home. Do you want to hear more demos? Oh, come on. Okay, I try, Bern. I'm trying to give them some energy. So I'll show you another. Here's a little fun thing. So here's some code I'm going to show you. Let me just kill all this for the moment. I have to just uninstall Docker as quickly as possible, because it makes me feel not good. All right. I'm just joking. Just joking. I don't hate Docker that much. Here's our datetime function. It returns a stream of integers, right? Which is the number of seconds since 1970, because that's how computer people like to measure time, which is totally weird. But nevertheless, this is that dt value. We're storing it there. And then down here, I'm just putting 4 random variables, 0x, ix 0, 1, 2, 3. And I'm using this special syntax, dt with curly brackets. 1, 2, 3, and 4, or 0, 1, 2, and 3. And what this means is the value from date time is the current value. But if you do curly brackets 1, that means it's the previous value. Curly brackets 2 is the previous value before that, and so on. So we can actually look back in the past and see what value something was. And that's really cool. So I'll show you this I'll show you this quickly, just to prove to you that it works. So I'm running this on the left. Oops. So you can see here, I'm just printing out this stuff. You can see this is the current time, a second ago, and so on. And that's running in real time. Okay? Make sense? Is that possible? Yes. So why is this useful? Here's a picture of something from my house in Canada. What is this for anyone who is a thermostat? And thermostats have a very interesting property. Does anyone know what it is? Besides controlling the temperature of your house or apartment. Anyone? Yes, it's something called hysteresis. This is some sort of weird thermostat that's a clearer picture, but I don't know what the units are. It's from some other country that doesn't matter. And what hysteresis is hysteresis is a property. You have a certain set point. So I want my house at 20 Celsius, for example. And if it goes up a little bit higher than that, the heater is going to turn off. And then the temperature is going to drop, and it's going to click back on. And if the heater was super efficient and the thermostat had no hysteresis, it would click back and off. Click on and off again. Click, click, click very quickly. And if this was something like a VM, we wouldn't want this to happen. We don't want to flip-flop things very quickly. So hysteresis actually can tell you, I want a bit of a threshold before I go back on. Does that make sense? So I can actually model this in MGMT. You want to see a demo of this? All right, so I'm going to run MGMT on the left. And I'm just going to run this command here. It's, again, I'm printing out what's in the text file, just for observability, so we can see what's actually happening. And I'm running verse list -- all, right? Just so we can see the state. I'm just being annoying. I'm saying libvirt, how many machines are running, how many machines are running. And you can see that MGMT has actually started up these first 2 VMs, MGMT1 and MGMT2. And it's also printing out this load here at the top. That's my current system load and the threshold right here. The code here is about 10 lines of code, so it's really simple. And what I've done is I've asked MGMT, when I hit the threshold of 1.5, I want you to shut down one of these 2 VMs, please. And in addition to just shutting down that VM, I want to stay shut down until I've dropped below 1.5 for 10 seconds. And only then will I reschedule the VM. Does that make sense? So normally these would be Bitcoin mining or doing whatever, but just to fake the load, I'm just going to actually run a whole bunch of tree commands to heat up my laptop. And watch, when this hits 1.5, this value, one of these 2 VMs hopefully should shut down and just disappear. All right, so keep an eye on it. Okay, it's going up. Maybe lib64 has something boring. Okay, 1.4, it's getting pretty close. And boom, there. See, you see how MGMT2 is gone? Just have MGMT running. So MGMT1 is the only VM running, and we're at 1.7. So watch, once we go below 1.5, nothing's going to happen until we've been below for 10 seconds. So let's watch. Not touching anything. Okay, 1.8. The kernel recalculates the load every 5 seconds. That's just internally how the kernel does it. So that's why you only see a change in the value every 5 seconds. 1.6, so it's still dropping down. You can see the machine still shut off. 1.50, I think that's not quite there. So next one, okay, 1.3. So now we're waiting 10 seconds. Okay, 5 seconds, 4, 3, 2, 1, boom. And you can see it started back up. Is that cool? Do you like that? You can clap, yeah, go ahead. So this is a completely simple example. This is just a silly example of scheduling one VM. But now if you start to think in your mind about combining the auto-scaling stuff that we did with hysteresis or different resources, container resources, vert resources, all of this stuff is completely agnostic to what resources you do. So if for some reason you didn't want to do this with a vert machine, you wanted to use containers, you can do that. The whole concept, for example, of Kubernetes, where you're fixed to like container resources, or basically it's too structured, too hardcore, and I think this general approach with the DSL, this friendly language that allows you to program these things, is much, much better. And all the examples I'm showing today, they're in the GitHub project in the examples/lang folder, and you can try these out at home on your own laptops. Cool? Cool. All right. I got only about 5 minutes left, so I'm just going to go through the end. So the Mgmt project, it's still pretty new in the grand scheme of things. It's not a big fancy project with millions of dollars of Google development money. It's just me working on it and all of the people on the internets, which is huge when you get patches from people. So there are still some bugs. It's not perfect. I think most of the bugs, I only actually know of one bug that's probably a little annoying, but I only found out about it yesterday. But basically, most of the bugs are all gone. So any bugs you find are probably very small things that need fixing, and we're just sort of polishing right now. It's sort of in the final stretch. Functions that are built into the language, for example, like all the math functions and random things like that, some of these need to be added. There's still some missing. Maybe there's some new real-time event source, for example, for a temperature sensor or something like that that you'd like to add. So there's still some things missing, but you can get a lot done today, and it's very easy to add new ones. New resources. So we have resources for virtual machines, containers, and files, and packages, and services, and all bunch of other stuff, but it would be nice to even have more cloud-type resources, kind of like Terraform. We have an EC2 resource, but nothing else right now that's cloud-like, if you're into that sort of thing. So that Exascale or Exascale company, they could add an exascale management thingy, I don't know. New features, we actually don't have function values, which is kind of obscure in terms of programming, but it might be fun. You can't actually store extremely large files in MGMT. So if you want to store ISOs, I'll tell you about how this works on my talk tomorrow. But it's not perfect, but it's pretty darn close. And there's a few bugs, but nothing serious. How can you help? Do you all want to help? Maybe. Fair enough. So you can use this, test it, patch it, share it with your friends, document it, start on GitHub if you're into that. You can blog it, you can tweet it. If you have Twitter, I'm Purple Idea. You can hit me up and be like, hey, hack on it with your friends, hack on this stuff. And the sad thing is MGMT needs funding, because basically I left my job at this Linux company to work on this free software stuff, which totally is bad financially. So if you'd like to donate money, sign up. I have a Patreon thing, and finding a hacker is very sexy. So you should definitely get on this. Let's just recap. It's a very bad recapping joke that I make in all my talks. He puts the cap back on his pen. So we have an IRC channel. We're about 70 some odd people hanging out on Freenode in Mgmt Config, so come chill with us. There's a Twitter account if you don't like hearing crap that I have to say, but you want to hear just MGMT news. And we have a mailing list as well, where there's announcements and light discussion, which you can also join. There's the technical blog of James. You all know about the technical blog of James now, right? purpleidea.com, check it out. There's some old talks online, whole bunch of blog posts, and I've got 2.5 blog posts that are written right now that I'm going to be putting out shortly. And you get early access if you donate money on Patreon. OSDC, that's here. Tomorrow, I'm giving this super advanced talk, which will be much less fun, but super informative. So if you want to see stuff that almost no people in the world know about, I'll be showing that tomorrow for your pleasure. You all have to help me out. If you like this talk, see the very tall man who's hiding in the back of the room? His name is Bernd. He looks like this whenever he's holding a water bottle. Before you leave today, anytime today, 1 a.m. in the morning, doesn't matter, go up to him and be like, hey, Bernd, James's talk was really cool. I like his software. Could you ask NETWAYS to help us do this stuff? If everyone bothers him for 2 seconds, it'll be super hilarious. You know, he's talking to some girl, trying to be cool, like super tall, and someone's like, hey, excuse me, Bernd, I have to tell you something. James's talk was great. Think of it, if all 100 of you did that, would that be funny?
Yes.
Okay. If you promise to stick these on your laptops, come up. I'll hide over on the corner, and I'll give you a free sticker if you promise to use them. Is that cool? Thank you very much. I have 1 minute for questions or 0 minutes?
0 seconds.
I have 0 seconds. So I'm around here tomorrow and today, so feel free to come grab me if you have a question. And yeah, that's it. Happy hacking.
Thank you, James.